Perfect. Hi, everyone. This is Rob. Stay tuned. We're going to be starting the webinar in about 3 minutes. Thank you. Hi, everyone. This is Rob. We'll be starting the webinar in about a minute. Thank you. Hi, everyone. I'd like to welcome everyone to the Data Architecture chapter for a pass. Today, we have Mike McGhee, and he's going to be presenting on SQL Server copy data management. Actually got to meet Mike last week at the Nutanix conference, and that was an amazing conference. If y'all ever have an opportunity to go to it, I highly recommend it. Oh, it went too fast. Sorry about that. Let's go back a screen. So here are some upcoming webinars we're going to be having. You can sign in to the Data Architecture chapter site and then sign in to watch these webinars upcoming. Next week we have one. Then we're going to have several that are actually on the site. I just presented 3 here, so check it out. as always, we like to thank Nutanix. They're our sponsor. They've been our sponsor for a while, and they really make everything possible. Um, and thank y'all, Nutanix. They have a lot of great tools, and check them out at that link if you have a moment. So we also have a brand new sponsor, HVR, and their link is at the bottom. And thank them for supporting our chapter and making these sessions possible. So PASS is going to have Summit this year, and if you'd like to go, you can save some money here. If you use that VGDISENKE code, you save $150, and we'll get credit, and we'll be able to give away some monies during the year because of y'all using that code. They also have the pre-cons and a lot of great speakers, as you can see here. So when you sign up, there might be a great session, so check out the pre-cons. So here are upcoming webinars, and you can see here's ours at the top of the list. And if you have time, there might be another session you want to check out. So just sign into PASS and you can see them. And there's no cost, it's just all free sessions. They're usually about an hour. Here's some more. We have several sessions on this list, as you can see, where there's 3 there. Upcoming SQL Saturdays. So if you have some time, you can check out SQLSaturday.com and sign up for SQL Saturday and get free training sponsored by PASS. So, it's pretty cool. They have one here in Baton Rouge once a year, and I tend to go to it. So if, you're in Dallas or New York, you may want to check it out. So with that, I'm going to change over to Mike. Mike, can you hear me okay?
Thanks so much, Rob. You sounded very, very good. And thanks everyone for joining. So I'll just flip over to my screen here. Hopefully that's coming across okay.
Yeah, Mike, I'm going to mute out, but if we have questions, do you want to take them at the end of the session, or do you want to take them kind of during the sessions?
You know what? Either way, if we can take them real time, that'd be great in context, because sometimes that can lead to a good conversation around that specific topic. So I wouldn't mind it, and we'll have plenty of time to do that. Okay. So yeah, by all means.
If I see it at a breaking point, I'll just stop you if you don't mind, and we'll kind of wing it. All right.
That sounds great.
All right. I'm gonna turn it over to Mike. Mike, thanks again.
Yeah, thanks everyone. And thanks, Rob. And like Rob mentioned, so my name is Mike McGhee. I do work for Nutanix, and I'm a senior technical marketing engineer. And for the purpose of this presentation, I'd like to really generically and focusing mainly on SQL Server, but also across different vendors, focus on copy data management. And it's a pretty simple concept, and most of you are probably familiar with it. But just to give a quick definition, when we consider copy data management, fundamentally what we're talking about is the capability or need to create multiple copies of a source application, or in our case, a source database like Microsoft SQL Server. There's a lot of different methods by which you can do this, and there's a lot of reasons why you would do it as well. So, but just to level set on the concept, creating a bunch of different copies for different purposes. So throughout the presentation, what I like to focus on is what are some of the ways in which we can do this both natively and with third party. What are some of the considerations we should be looking at when going through these methods, based on your use case, and how can we blend some of these solutions together to get you really where you need to go for the right use case? Because every developer or every QA group, or if you're doing some form of reporting, or if you're doing some form of surgical restore, all those are going to have different performance requirements, different data masking requirements, multi-tenancy requirements, and who's making these copies and who has access to mount them and use them, etc. So I'd like to focus on that in more detail. So there's lots of different reasons for why we make copies. The most primary use case is backup and restore, and the most common method I see that people use to this day, regardless of what they're going to use the copy for, is backup. So make a backup copy, and you can do log shipping, make a backup copy, and you can restore it for reporting. You can restore it for surgical repair, et cetera. So backup is very, very common. Disaster recovery is also super common. It just for the purpose of getting off of maybe your primary storage and getting to a secondary site, secondary hardware. So if you do have a hardware failure, you're now in a different failure domain, both from a software perspective, but also from a physical server and storage perspective. And even being able to do this, not just for disaster recovery purposes, hopefully you'll never have to actually go through a DR event. So in many cases, what you're doing is you're practicing and you're testing. So making copies to make it easy to do a DR test, not something that's painful or causes a lot of downtime or takes a whole weekend. And there's different use cases there where you might need to fail over and run in that secondary site for X amount of time. So, that secondary site and the way in which you created that copy needs to be performant, similar to your primary site. So there's considerations there as well. What we hear a lot of, especially in our space, is using a secondary copy for reporting and also quality assurance and development. And there's lots of different methods to, or really requirements around what that copy needs to be able to do. Is it read-only? Is it writable? Can I change the schema? Can I change the indexes, et cetera? So some people have those types of requirements where, it needs to be fully writable and needs to be independent. Some people have requirements where, read-only is perfectly fine. So things to consider there as well. And even for migration, using native tools, backup, always on, et cetera, for the purposes of migration helps to, again, make a copy and give you to maybe a different version of SQL even, but even just using something like backup and restore, for example. So lots of different reasons why we all make different copies. And the reality is these copies grow exponentially over time. And a study done by IDC shows that the majority of the storage that we use for applications and database end up being some form of copy data, backup, DR, reporting, et cetera. And most companies have hundreds of instances of given applications, primary, QA, dev, reporting, et cetera, that represent tens of copies of these instances. So it's not 200 unique ones, it's multiple copies from maybe one source to multiple destinations. And you see that represents a majority, over 82%. So this becomes a management problem. How do you manage all these copies? How do you allow users to access them? How do you keep them under control from a growth perspective? How do they impact your overall budget? You can see it's a huge cost for maintaining these additional copies. So this is a key area for anything you look at to help, to make it easy to use, to make it multi-tenant, and to make it efficient. So that cost, as you saw as a part of that study, would be mitigated to some degree. So like I mentioned, there's ways in which to make these copies natively, and there's also third-party methods. So I like to start off with most common methods I see using native SQL Server tools for creating copies. And like I mentioned, backup is really one of the key ones that I see across the board. Even going back to SQL 2000, which I still see in production today, people using backup and restore methodologies for creating copies for reporting instances, for data mining, even for setting up DR for things like log shipping. Transactional replication, we see every so often, that publisher subscriber model or merge replication. Generally see it more for distributing transaction across multiple systems, more so than two different purpose-built systems. But there are cases where people attempt to use transactional replication for creating other copies for different use cases, and depending on the goal there, it may succeed or may have some limitations. We'll talk about that. Always on availability groups, depending on your version of SQL. Most people have upgraded to a point where they can take advantage of always on in some way, shape, or form. There's some licensing considerations around that, depending on your version, the number of copies that you need. But a common use case is read-only secondaries for read intent reporting, and also for backup offload. There also are database snapshots that you can leverage. We'll talk about those in more detail. Essentially, you're taking a snapshot from that primary copy that's running within a given instance, read-only based snapshot that you could use for reporting, but there's some limitations that we'll talk about. And lastly, there's also storage or backup vendor technologies, which we'll talk about in more detail, and what you would want to get out of that style of solution as well. Now, I mentioned some of the limitations you might run into. Some of these technologies, backup, transactional replication, et cetera, might work perfectly fine for your given use case, but some things to look at. So, for example, if you're looking at a backup and restore use case, one of the key things there is, one, if you're taking a backup for the purposes of making a separate copy, that backup is a streaming method of copy creation, as opposed to something like a snapshot, which may be instantaneous depending on the method that you're using. So the first part is the streaming backup of that copy, and then the streaming restore of that copy to that secondary site, to that secondary instance that's running out there. And I've worked with a customer recently where the timing of that was too long for their given window, to where they had to take a system down, do this full streaming copy, do this full streaming restore, and then bring that system back up. So that window was untenable, was too long for reinstantiating that copy for the purposes of their reporting instance. The other thing around backup and restores is the space consumption. Because it's not snapshot based, you're consuming 100% of that storage. And that's really going back to that IDC report of where the majority of the storage that people use end up being for these additional copies, especially if you have more than one. Now, there's storage vendor capabilities to help you reclaim that, and we'll talk about that in some detail, such as compression and deduplication, and even some native backup methods, native compression built into SQL itself. Now, from a transactional replication perspective, I kind of touched on this, where you're doing transactional replication between multiple instances of SQL. The most limiting factor there is really the way in which the data is formatted, your schema, and whether you need to make any modifications on that replica that you're using. If you're using it for test and develop it for QA, if you're a developer, you might want to test out different indexing against that copy. You might want to transform the data, do some additional normalization to see if you can enhance or improve query times, et cetera. So if you're restricted by the format of the data from the source, that's going to have some impact on your flexibility in doing those sorts of use cases. And I saw Rob mention that Kendra Little's going to have a presentation in the next few weeks, and she actually wrote a great article through her years with Brent Ozar that I've included a link here, where she goes through some of the pitfalls or just some of the considerations if you are using transactional replication. Should you be trying to use that for refreshing your dev and pre-prod environments? And she has a pretty pointed opinion, as you can see from the title, won't refresh your dev or pre-prod environment. So I would recommend you check that out if you are considering that as one of these methods. Always on availability groups is a good option. When you do have multiple replicas with AAG, you're essentially going to have a read-only copy on that secondary system. A lot of use cases, that's perfectly fine. That's great. You are incurring the additional replication costs from the source side in real time as you go, but it is at the transaction level, which is great. That's efficient. Doesn't require a lot of replication bandwidth. But if you do need to modify that data, you might have some limitations there with respect to always on. And then further, with database snapshots, not only are those read-only, they're also running on the same instance as your source. So if you're trying to consume different compute, different memory, and really lead to a separation in the environment to where your test, your dev, your QA is really autonomous and it's not impacting production, snapshots, while they're efficient, they're quick, and when you create them, they are limited in that sense, where they're essentially running on that primary source. They're also considered copy on write, and this is where we'll start to talk a little bit more about the way in which you create snapshots, because there's copy on write technologies, there's redirect on write technologies, there's autonomous snapshots, there's one like this where they're read only, et cetera. So we'll start to get into more of those details. But these are the general limitations that you'll run into based on these different methodologies. So that leads people to look at or really turn to different vendors to help solve the problem. If they don't want to do it with native tools, if they want something to ease the management of it, to make it multi-tenant, to lead to additional storage efficiency, et cetera, a lot of the backup or primary storage platform vendors have some form of solution with that. And I think that's one of the key things to look at is, if you're, running on NetApp, for example, and you want to use something like Snap Manager, that's essentially creating snapshots from your primary storage. Where if you're looking at someone like Rubrik, for example, Rubrik is offering essentially a backup appliance where you would back up from your primary. It could be snapshot based. You would read from that snapshot, put it on a primary backup appliance, and then you could technically take snapshots from that appliance and present it out to different server instances, different SQL instances, et cetera. So depending on the use case, the solution could come from a backup vendor. It could come from a primary storage or virtualization vendor. The snapshots or associated data could be on the primary storage as you run it for reporting or what have you. It could be primarily from a backup copy that could be a separate storage appliance that has different SLAs, different performance capabilities. Your primary storage might have lots of solid state media, very, very fast reporting. You might, when doing some kind of test or QA, get similar performance to production in that sense and get a better idea if you are trying to tune queries and whatnot as a part of the use of that secondary copy. Whereas if you're doing that directly from a backup appliance, that might have different performance requirements, or you'll end up with different results, which may or may not help you if it's performance tuning, et cetera. And to get to that point, you may have to copy that data off of that backup appliance. Not necessarily a bad thing, being that it's separate, but then that's additional copy that would occur back to primary storage, if you will. So just some of the things to consider when looking at these different solutions. And to look at it in a little bit more detail, what should we expect from, if we're going to go with a third party, if we're not going to use existing SQL Server tools, and we're most likely going to pay some costs, maybe it's a licensing cost on the primary storage, maybe it's a separate company or separate piece of software that you'd have to purchase. So you'd want this to really, really solve the problem and make it easy. So this is just really a list of the things I would look for when looking at this style of solution. And the first, as you saw again from that IDC report, is storage efficiency. So what kind of benefit do I get from deduplication, whether it's on the primary storage or deduplication of the backup appliance itself, if you're going to use that for the additional copies, or if it's not dedupe, is a copy avoidance. And when I say copy avoidance, it's really a snapshot. The idea that you're making an autonomous copy, but it's reference-based, it's pointer-based, it's not a full copy. And that helps from both the creation perspective, it'll be super fast, but also from efficiency perspective, it's not going to take up any additional space until you start writing to either that primary copy or that secondary copy or third copy that you happen to create. So I look at these as kind of the same. If you're avoiding creating the copy to begin with, you're essentially deduping, if you will, that copy. And again, that's the most efficient way to do it. Or, different vendors have inline deduplication, post-process deduplication, different granularity at which they dedupe, which is very important with SQL and the way you make those copies. SQL has 8K page headers on every page that consumes data. Those can be unique. If the deduplication engine is fingerprinting or really hashing at a larger layer, it'll have a harder time finding redundant data within those 8K pages because the hash is at a larger size. So keep that in mind. In many cases, dedupe technologies in and of themselves don't dedupe SQL all that well, whereas a copy avoidance technology, just taking a snapshot and forking multiple from a source, is going to give you the benefits of dedupe without that kind of unknown of how much efficiency am I going to get. Another thing to look at is the granularity of the application. Some vendors do things at the VM level, which is great, but you really want things at a more granular level if you can get them, really at the database level. The use cases I see, especially from a reporting or test and dev scenario, is you'll have a separate virtual machine or a separate server that developer has, and they just want a copy of the database. They don't want a VM to be copied from production, brought online, and then it's the production VM, which would have to, re-IP, change the name, maybe add development tools, debugging tools that aren't there in production, and have to do that every time you do a refresh would be somewhat not impossible, but just makes the solution a little bit more clunky and a little bit more difficult. Whereas if you can refresh databases at the database level, just detach the database, unmount your volumes, refresh the underlying storage, do the reverse, bring it back online, and do that to something that's already instantiated. It makes that much easier to do. And some solutions you can still do that, but it might be scripted. Other solutions might have that baked in. So I would definitely pay attention to that, see how far up the stack that given vendor or application goes to get you to that database level. That, like I mentioned, ties right into portability. So we want to be able to take a source and copy it to multiple targets. We want it to be flexible. We don't want to have to copy the entire VM from the source to instantiate the target. And we want that to be done at the right user level. So we don't want to have the storage admin have to log in to kick off these processes. Or, I mean, you could technically have scripts to run and refresh these copies, but it'd be great if a DBA could, without intervention from a server admin or virtualization admin or a storage admin, to go in and say, here's the snapshots, or here's the copies that I want to use, and I want to, you know what, I'm going to run a set of tests. I want to take a snapshot, and I want to use it just to refresh this the specific environment that I have access to, and not impact other instances from other users that are out there. So that's an important aspect. Performance requirements. So I mentioned this to some degree, the idea of, if you're doing some level of testing that would require you to match the performance from production, you may be looking at something that's taking a snapshot from your primary storage array, from your primary hyperconverged system, to do that. Therefore, it's going to have similar performance. Your server that you're using for that testing is going to have similar memory and CPU configuration. But in a lot of cases, you're over provisioning on your test and dev and DR targets. So you're sharing CPUs. Most cases you don't have memory over subscription, but you very well could. Or maybe you're just running on slower media, and that's not a big deal because it's functional testing. Does something work? The performance is somewhat secondary. It's more about testing with as up-to-date data as you can. Performance is secondary. So knowing those SLAs and knowing those requirements will again impact the solution that you end up choosing. And going back to the granularity at the database level, it's one thing to take a copy at the database level, but you also want it to integrate with the database. So in the snapshot, or really the copy data management sense of creating a snapshot and treating it like a backup, that's where things like the volume shadow copy service comes into play, or directly to SQL, you can call something called VDI, or the virtual device interface. And that helps to coordinate a snapshot operation with SQL. So the idea of taking a snapshot, freezing IO before you take it, thawing the IO, collecting a metadata document, so that you can really take what is really a point in time copy that's, a snapshot based copy, and treat it more like a full backup, if you will. And we'll talk a little bit more about that. And when you do integrate at that level, it gives you the opportunity to add in log management as well. So full backup or a differential backup, you can then take your log backups, do truncation. Sometimes that's separate from that product. Sometimes the product will give you a full copy, and then you have to manage the log backups and log truncation and the schedule from there. Also on the recovery side, other solutions build that in. So you can use them as a primary means of creating a copy, and then they would actually manage the log piece of that as well. So that's something else to look at and consider. So I mentioned taking snapshots at the storage layer, and I just want to draw a distinction of some of the benefits or really what I would consider the proper method for taking a snapshot at that layer. I mentioned database snapshots within SQL. Those database snapshots are copy on write. And what that means is when you go to update data within the database, it's going to first, before it allows that update to occur, copy the data to another location, and then allow an in-place write to occur to that record or whatever is being updated at the time. So copy on write, if you hear that term, that tends to have a connotation of a performance penalty. And if you read SQL documentation, it mentions that there is a performance penalty when it comes to that copy on write operation. Ideally, what you'd like to hear is redirect on write. And the idea there is that we're not going to copy data just so we can update it later in a synchronous fashion. We want to just simply, if the new write comes in, we just want to redirect it to another area of that LUN, of that disk, of that file system. So the idea is you would take a snapshot. It would be a pointer of the existing data that for that source. And then if someone were to attempt to write, in this case, say we were updating the same sector or the same extent that represented, say, D1. In this case, we're going to call it D2. We're not going to copy D1 away and then let D2 do the update in place. We'll go ahead and just find another area within the file system, do that redirect on write, and now that's going to essentially act like a high-performant primary copy. What doesn't impact the base copy, if you will. It's just a re-reference. So now that vdisk1 that you can see is no longer referencing D1. It's now simply referencing D2. And then if another snapshot were to come along based on that previous virtual disk, you now have a new disk that's referencing D2 from the start, as well as those original blocks within the base vdisk. Now, if you're familiar with some snapshot technologies, as you go along, you take more snapshots over time, there's this concept of a snapshot chain. And these snapshot chains can get deep. So, you keep these existing pointers around. There's different copies that may or may not require access to it. So for example, in this case, that block D1 may not be needed over time based on the vdisks or the snapshots, if you will, as they're created. And we would want to collapse that. Or if there's a vdisk that represents those bits that we don't necessarily need, we can redirect them to another copy. That concept is really called collapsing the snapshot chain, or we're making it shorter so that when you traverse it, you won't have as much of a performance impact. So you want to ask your vendor, hey, what are you doing with these snapshot chains? Are they left in place? Are they only removed once we delete certain snapshots? Are you collapsing them ahead of time? And also, how are you storing the metadata? Because the big thing that impacts performance with these copies is the metadata associated with that snapshot chain. So is that built to be in cache? Is it something that has to be retrieved from spinning media? Is it something that has to be retrieved from SSD? And if you do any testing in this space, especially if it's a large database and it's a primary copy and you're going to be taking a bunch of snapshots from it, you want to evaluate what happens if I have a deep snapshot chain. If I take a bunch, don't just take one or two and say, oh, it worked pretty well. Take a bunch, see how far it can go, run it over time, and that'll give you a pretty good feel for what kind of impact you would have as you get these deeper chains when testing out these styles of solutions. And when you do create storage level snapshots, I like to categorize them in two ways. Because if you're doing primary storage snapshots for the purpose of copy data, you want to hold IO when you create these copies. There's ACID requirements, atomic, consistent, independent, and durable requirements that you want to have with the database. You have write order fidelity, write ahead logging, etc. You never want your data to get hit a log. So you want some form of consistency technology for creating these copies. I mean, heck, you might even have distributed transaction across multiple instances where you could start looking at things like consistency groups to make sure that those copies are dependent, right, consistent. So when you create a copy using snapshots, there's, to me, really two ways. There's the application consistent method where you're calling into the operating system, you're calling VSS or VDI, like I mentioned, to quiesce SQL at the SQL layer, or you're doing a consistency technology within that storage vendor to hold IO at the storage layer to allow you to create that crash consistent, if you will, copy. Now, when you create a storage level snapshot and you haven't integrated with SQL, to me, that's a restartable copy. So it means I can take that copy, I can attach it. If it's a VM, I could boot that VM, but I can't do anything else with it. It'll come up, it'll come online, it'll go through a recovery process, it'll roll forward or roll back, depending on the state of the transactions. But to me, that's not a restore. You're restarting it. You're at that point in time. You can't do other operations, which is fine. It's just that point in time. It's great. And you can go on from there. But for me, a restorable copy is one that you can manipulate further. So I can restore into recovery mode, standby or no recovery, and then I can apply logs to it. So if I want to roll that copy forward, stop at log mark, stop at point in time, you're able to do that. And now that snapshot isn't just restartable and point in time. It's something that really is restorable, can be manipulated, can be used to instantiate copies for different purposes. Even in some cases, if you want to create a copy for setting up AAG or anything like that, it helps in that regard as well. So just to give you some background on VSS, if you're not terribly familiar, there's a few components. The ones that you'll see within Windows most prominently are the volume shadow copy service, and really that's a middleman or a broker that's going to communicate between the different services that are requesting a particular copy. So SQL Server will have its own SQL writer. You're probably familiar with that service that runs within Windows, and that's going to be the entry point into SQL to communicate when to freeze IO, when to thaw IO, etc. But you also have a requester and a provider piece, and generally these are going to come from a third-party vendor for coordinating these operations. So the requester would really be the front end, the CLI or the API for specifying, hey, I want to make a copy of database X, Y, or Z. And then the provider piece of it is, how do we make that copy? What's the engine, if you will, that's going to be really passed off? So when SQL is in its state, volume shadow copy service will be, okay, provider, make your copy and let me know when you're done. Provider comes back, hey, I'm done. Finish stuff up with the SQL writer. Shadow copy service will say, okay, great. Pass it back to the requester and say your copy's done, or here's where you locate it if you need access to it, etc. So from the vendor, you're going to look at what's the requester application, and that falls back into the requirements I mentioned around, is it GUI, is it CLI, can it be automated, does it have built-in scheduling, is it multi-tenant, all that good stuff. And then from a provider's perspective is, how's that copy being made? Hopefully it's a super fast snapshot, a high performance snapshot, redirect on write, metadata in memory, short or at least backup or snapshot chains that can be collapsed over time. So like I mentioned, some of the benefits with VSS is you're not necessarily relying on the storage vendor to freeze IO when you're making these copies. VSS is doing that for you. What it will do is quiesce the write transactions that would come into SQL. So reads can technically continue while you're in this freeze state, and generally you're trying to keep that under 10 seconds. So 10 seconds is the default window where VSS would otherwise time out if you didn't create the copy within that given point in time. So it's really meant for snapshot operations. But do keep in mind, if you do have a VSS operation come in, freeze certain write transactions, just through the nature of database locking, that could very well impact reads as well. So if you do an update to a table, you're updating a row, some read comes in, depending on the table hints you may or may not be using within your queries, you could see impacts to read during this quiesce as well. Not a big deal. It's going to be shortly maintained. But one thing to keep in mind, some vendors in this space not only do hourly snapshots or daily snapshots, some of them do continuous snapshots or really continuous replication. You're likely not going to look to use VSS for every single one of those copies. You can commonly it's called continuous data protection, or CDP, where you're always continuously taking mini snapshots and replicating them to other platforms or what have you. And you can also use these in a lot of cases to almost have like a DVR type capability of restoring the database back to production, or even putting I guess very, very specific point in time into those secondary copies for dev and QA. So based on that super, super low, maybe even like minute type snapshots, you're likely not going to use VSS for that. That's just, you're not going to be freezing your database every minute just for that purpose. So that's where you're really relying on essentially a journaling mechanism at the storage layer to do that. So VSS is great from that perspective, but it shouldn't be relied on 100%. You really should trust the underlying storage vendors to quiesce the data at their level, because ultimately they're going to know right order fidelity, how the data is coming into the system, how things are journaled, and give a good experience there. But the benefit of VSS is you are going to get application consistent. You are going to get a metadata document associated with that copy. And that document is going to allow you, it's essentially a backup header. So if you ever read the header of a backup file within SQL, as information about, log sequence number and data files and when it was taken, et cetera. This metadata document functionally takes over that role. So when you do a restore, you can use it in combination with VSS to put that database into a recovery state. Whereas if you didn't have that metadata document, you would be stuck at that restartable copy, like I mentioned, point in time, connect it, restart it, roll forward, roll back, and that's what you got. Whereas you have VSS with the opportunity to then apply diffs, apply logs, et cetera. So just to put this in full context, especially from a VSS workflow perspective with respect to backup, because that's really what the benefit of VSS is. You're getting the ability to make a snapshot, but within a backup style workflow. So most of you are probably familiar with the general concepts of backup and restore with SQL, where you would take an initial full, you might take a sequence of log backups. After that initial full, you might on a different day take a differential, which will be all the changes since the last full backup, and also take a sequence of log backups from there. When you then go to do a restore, depending on the point in time that you really want to get to, if you want to go to the point of recovery, say you backed up the active log and now you're going to go do a restore, you would essentially do the full. You wouldn't need these logs because you had a differential, and then you could go ahead and restore that log chain. So what you're getting when you perform a snapshot with VSS is you're replacing that full. So that full would be a snapshot restore instead of a streaming restore from say a repository. So that initial full will be very, very quick in how fast it's put back into production. And then you would do some form of management from the differential all the way through the log. And so just to bear that out and give you some ideas. So imagine having a source first machine or a source instance with multiple databases. Maybe you have a target VM that you're going to have for your DBAs or your administrators. You would start taking snapshots at the VSS layer. In this case, we're capturing database 1 and database 2. And then over time, as you take these, what really represent a full copy, you would take your incremental log, your differentials as you go. And then you would have functionally the same capability that I just showed you on the previous slide. So if you wanted to, say, for example, take one of those snapshots and instantiate it to a separate environment, that should be a capability that you're looking for. And say if you did have a failure in your production environment, one of your databases got dropped, a table fell off or what have you, to where you want to do a full restore and not something surgical, say from another machine, you could do that restore, which would again be snapshot based, and then restore your differential and logs in order really as required. So like I mentioned, I work for Nutanix. We have a product that we're in alpha stages right now, where we're working on really solving the problems, removing those limitations, and doing it based on really those best practices that I mentioned, or really the functionality that you would want to see. And what I like to do is show you what it looks like, because it's in alpha stages now. We'd love to get your feedback based on your use cases, your requirements, but hopefully we're hitting the mark on it. So, just to kind of mix it up here a little bit, I'll go ahead and change from the presentation and just give you a quick demo. Maybe this will liven up some questions, or if you have any feedback on what you would want to see in this tool, what it should do. We'd really love to hear it. So we announced this last week, and again, it's in alpha stages now, but it's called Era. But you can even ignore it as a Nutanix product and just think of it as really a dashboard and the means for deploying databases, capturing snapshots, or really an SLA of a given source database, and then instantiating those copies into one or multiple targets. So we want to put all that information up front and make it as easily to consume as possible. So you can see the number of source databases that we would have registered, the number of clones, meaning how many copies of these have we instantiated for other purposes, how old are those copies. We like to use a concept called a telescoping schedule. So you'd have X number of really short-term copies, if it's kept every day or every hour, what have you. then you'd have X number of weekly copies and X number of monthly copies beyond that time. So getting quick visibility into that. And again, this would be multi-tenant. So if a DBA logged in, they would just see their sources and their clones, but they'd get an understanding of, am I saving space? How much, if these are all snapshot based, what is my return on investment? What's the value of me doing this? Versus if I had a 100% autonomous copy that consumed all the space and I wasn't deduping or compressing in the back end, what would that look like? So the idea is pretty simple. You would come in and you would register your database servers. In our case, we're going to support different servers along with SQL Server, but you would register those. You would select the databases within those instances, your sources, which ones are going to be my source environment, and which instances are going to be my clones. Because as you imagine, you have multiple copies, you're going to have a lot more clone targets based on, is it the development, is it QA, is it reporting, et cetera. But you're also functionally getting an additional copy here for recovery purposes as well. So you can restore back to production. And if we're using VSS, you're going to get that recovery mode roll forward capabilities as well. So once you registered your databases and your database servers, you come up with a service level agreement, or really a schedule for how frequently you want to take snapshots, how often do you want to maintain them. These would be applied to the different copies that you would create. So these would occur over an ongoing basis, along with the fact that you'd be able to do on-demand clones and on-demand copies as well. And as you apply these SLAs to registered instances, registered databases, over time, you're going to have what we refer to as a time machine, but really it's just a logical representation of all those copies that you've made over time that you'd like to use in some way, shape, or form. So like I mentioned, you can take new snapshots, you can select a given copy, wherever that might be, and apply it to, in the case of a clone. So for example, if I select clone, I'll be able to choose which one on that day, for example. I would select, what's my target server from that point, and really go on from there. And the idea is it would take care of all the underlying snapshot creation, presentation to that server, mounting to the appropriate file system directories, attaching to, to SQL or to whatever database engine happens to be there. And then once you do create these specific copies, you want to be able to refresh them as well. So the DBA could come in, go to an existing, like say, dev copy, and then from there, go ahead and do a refresh of that instance to, again, using one of those time-based snapshots that we would have. So pretty straightforward, and hopefully very easy to use and understand, but it's a very powerful mechanism, and it's something that, natively, you can certainly use native tools to get there, but, a lot of cases you're cobbling together kind of a unique solution where there are going to be options out there to make this easy, to make it more efficient, to make it multi-tenant, et cetera.
Hey, Mike.
Yes, Rob.
So I got a question for this. Can it run scripts to scrub data so that the test data wouldn't provide like social security numbers, special information that you don't want the developers to see?
Yeah, that's a great point. It's something I had within the presentation and around, which I didn't really mention, around data masking. So I think over time the goal is to have that built, at least for Nutanix, to have it built into the product, and to have kind of pre and post scripts that you'd be able to run outside of any built-in function. So yes, there would be windows to be able to do that as a part of the mount operation. I know SQL has some, at least in newer versions, there's built-in, I think it's called dynamic data masking with 2016 or higher. So I think there's some permissions that you can set against the source database that maybe you wouldn't apply to a developer or someone else on the receiving end of that copy, where they wouldn't be, that data would be masked to some degree, but you would be dependent on setting that up, having the proper permissions, and that could cause some restrictions. So we are looking at a way to obfuscate or to mask the data and have that automated within the product too. That's a great bit of feedback to ensure we have that, because I'm sure, PCI compliance and other reasons you don't want to expose that information to multiple users, even if it's within the company that owns the data.
There is another question here. I'll read it at this point. So they're basically saying they have some production servers, and they're looking for some options to do real-time replication to different sites, and looking for your recommendations.
Yeah, I mean, real-time replication, if it's for DR purposes, depending on your version of SQL, I mean, always on is a great method for doing that. Something to consider, because when you're doing things at the database layer, you're really just replicating the log transactions at that point, or the transaction itself between sites. So the writes associated with that are only the log writes, or really only the size of the transactions that you're writing that would otherwise go to the log device. And then you also have storage technologies. We have partners and third parties like Zerto. There's Recover Point from EMC. Nutanix has native methods for doing that. We have something called near sync, which is a continuous replication technology. So there's different vendors out there to do that. But one thing to keep in mind, when the storage takes over that operation, you're replicating all the writes associated with the database. So you're replicating the writes associated with the log. You're replicating the writes associated with the data file as well. So what you checkpoint, what your indirect checkpoints, whatever it happens to be, those are writes that are associated with that replication as well. The benefit, though, is you can basically choose to replicate all your different applications and all your different VMs if you're using something below the application layer. I mean, SQL is important, but it's normally a piece of an environment. It could be a big piece, but it's only a piece. And it might have its own native replication, and you might have a DBA that's comfortable with that. But if you have a large environment, different apps, different databases, different middle tiers, et cetera, having a consolidated kind of common method at the storage layer to do that replication would be my choice personally. But it really, I mean, it all depends. But always on is great for continuous replication. Asynchronous replication if you have a really low RPO requirement. And the other thing to consider too is how agnostic do you need to be between the two sides. So some cases you might have existing EMC or NetApp environment, but you want to replicate that to a new environment that who knows what it's running. Some HCI platform, could be Nutanix. So now you need to reconcile, how do I replicate between different platforms that might not have a replication engine that works with each other. So third parties like Zerto are good there, or application layer replication helps there as well. I mean, if it's a homogeneous environment and it's the same underlying vendor at both sites, then native replication starts to come more into play at the storage layer, and it could be the same technology that could suit that bill. So it's very much it depends kind of question, but hopefully that gives you some ideas.
Thank you.
Is there any other questions? That's essentially what I have for you today. And again, I'd love your feedback if you have anything that you'd want to see in a product like this, any use cases. The data masking is a great example. Would love to hear from you. So it's michael.mcghee@nutanix.com, or you can find Mike McGhee from Nutanix at LinkedIn, or you can find me on Twitter too. It's at MCGHEM. So please let me know. Would love to hear from you.
That's all the questions we have right now. Sometimes I get email questions and I'll forward it to you, Mike. But it was a great demo. Thank you. This session is gonna be webinar, and we'll put it on the YouTube site. So we'll be sending out links later today or in this week, and I'll let everybody know if they want to watch it again. So thank you, Mike, for coming today.
Yeah, thanks so much, Rob.
I guess we'll just go ahead and shut it down. We also have a giveaway. We'll pick 2 people randomly, and check your spam mail. Sometimes you get these spam mails. It might be us.